If I were to ask you what colors the squares of A and B were, I imagine most of you would quickly say that A is a darker shade of gray than B. But what if I told you that A and B were actually the same color? It's okay if you don't see that. This picture is designed to trick our visual system. But once we have a connector of the common color between the two squares, it's much easier for us to see that they are in fact the same color. So what's going on here? Over the years, scientists have developed a human visual system model through the study of our eyes, and one incredibly interesting finding through experimentation is that our eyes are much more sensitive to brightness than they are to colors. And part of the JPEG compression scheme can take advantage of this, but to understand how, we have to dive into the world of color spaces. As we've discussed, the RGB color space is a combination of red, green, and blue color components. If we put each value on a separate axis in a three-dimensional space, we can see how all the possible colors are just a point on this cube. One aspect of RGB color space is as you progress on the diagonal from the origin to the color 255, 255, 255, you get gradually brighter colors. And in fact, the exact line between these points defines all possible grayscale colors, which are a direct measure for brightness. This idea of separating brightness is core to another color space called YCBCR. YCBCR stands for Y, chroma blue, and chroma red. Our Y component is going to measure the luma or brightness of an image, and our CB and CR components are going to encode the colors. If we look at the color space, the Y can be thought of as a single vertical axis with larger values encoding more brightness. Every cross-section of the space defines a range of colors at that particular brightness. For our purposes with JPEG, using the color space gives us direct access to the part of color that our eyes perceive best. As a result of being more sensitive to brightness than colors, one idea to compress our original image involves sampling less of the CBCR components and keeping all of the luma components.